Math 0332, Review 2, numbers 18 through 24. So before I actually get started on the first couple problems here, I want to just review exponents and some rules that you'll need to finish this test review. So whenever I have exponential notation, that looks like this, b to the nth power, where b is your base, so that's the number being multiplied, so base, and the n is your exponent, and the exponent tells you how many times to multiply your base. We also have another rule that deals with fractional exponents. So in order to evaluate a base that's being raised to a fractional exponent, you actually have to convert it into radical notation. So the base will go inside your radicals, becomes the radicand. The m is your exponent, so it's going to go out here, and the n is your index, so it goes right there. So we need to know these two rules to be able to do number 18, 19, and 20. So I'm going to do 18 and 19 for you. You can do number 20 on your own. So 18, you're given 9 to the third power. So all that means is your base is 9, so it's the number being multiplied, and it's being multiplied 3 times. So that's going to be 9 times 9 times 9. So you could do that on your calculator, or you could just do it by hand. So I'll kind of show you what you would have to do it by hand. So we know that 9 times 9 is 81, but then we still need to multiply it by another 9. And when we do that, we would get 729. So all you have to do is expand it, do the multiplication, and you'll get your final answer. Number 19 is maybe a little trickier because we have to use this second rule that we have up here. So you're given that we want to evaluate 36 to the 1/2. So in your head, you might not be able to figure out what that is. But we know that a fractional exponent actually converts to a radical. So the base goes inside my radical, and notice how the 1 is kind of on top. Well, I shouldn't have used red, sorry. The 1 is on top, right? So it's going to become my exponent of 1, and then the 2, it's on bottom, so you could think of it as staying on the bottom here. That's my index. So really you're doing a square root. So we don't have to write the 2 in, but I will just for note-taking purposes. So if we were to do the square root, because we want to handle the inside first, the square root of 36, you're asking yourself, what number times itself equals 36? So if you think through your numbers here, we would find that 6 times 6 is 36. Note that the numbers have to be the same, okay? So 36 is a perfect square, factors of 6 and 6. So the square root of 36 is 6. And 6, if we raise it to the first power, is just going to be itself, so it's 6. So looking at our next section, we have 21 through 24, and we're solving the equations, and you're told to check. And I'm just going to tell you right now that the checking on the test is a part of the credit. So if you don't check it, you're only going to get half credit. And if you check it, you're going to find out if your answer is right or wrong. So you really should be checking all of your answers. So with solving equations, we've learned that what you do to one side of it, you have to do to the other. And then also, if I'm trying to get rid of something, I'm going to do the inverse operation. It might be easier to think of that as the opposite. So whenever we look at number 21, we have x minus 4 equals 13. So my goal is to solve for x, meaning we want to get this guy right here by himself. So to do that, I have to get rid of the minus 4. And to get rid of minus 4, I would do the inverse operation, which is add. And if I add 4 to one side, I have to cross this equal sign right here and go and add 4 to the other side. So that's going to give me x equals 17, because 13 plus 4 would give me 17. But you have to check your answers. So right underneath it or to the side of it, you should be checking. So I think that my x is 17. So I'm going to plug it in to my original equation, and then I rewrite everything else as is. So instead of the x, I've plugged in 17 right here, and then we write everything else out from the original. Minus 4 equals 13. I like to put a little question mark there because I don't know if it's equal yet. But now if we look at the left-hand side, 17 minus 4 is 13. So 13 equals 13. Since the left side equals the right side, that means I can go back and box my final answer because it is correct. Moving on to number 22, we again need to get this guy by himself, the x. So we need to get rid of the 8. So you need to think about what is happening between the x and the 8. What operation? So this division bar, this little fraction, is division. So if x is being divided by 8, to undo that, I would have to multiply. Okay, and if I multiply one side by 8, I have to go and do the other side by 8 as well, multiply. So what's really nice is 8x over 8 would cancel. So this 8 cancels this guy out, and we're left with our x equals, then we do 9 times 8 to get 72. But again, before we move on, we need to check. So we think that x is 72. So I'm going to plug that in, and then everything else comes down from my original equation. So 72 over 8 equals 9. So again, this 72 is this x right here. 72 divided by 8, you'll find out that that is 9. Therefore, 9 equals 9, and we have a correct answer. So notice I'm going back up here, and this is my answer that I'm going to give. So this down here, the check, that's not your answer. This is just telling you that yes, hey, you found the right answer, but it's not your actual answer. You have to go back up here and box this guy. The x equals whatever number you get. That's your solution. So 23, still solving for x. Need to get rid of the 6. Think about what operation is happening between the 6 and the x, and it's actually multiplication. So to undo multiplication, we will divide, and if I divide one side, I need to divide the other. The 6x divided by 6, the 6 is canceled, leaves me with x. 180 divided by 6 is 30, so I think my answer is 30, but I'm going to check it. So we're going to have 6 times whatever we think our x is. So we think x is 30, so I'm just going to plug that in right there and see if that actually works out. 6 times 30 is 180. 180 equals 180, therefore my check worked out. Go back, box my final answer. So 24 puts a couple of things together. So we still want to get x by itself, but notice we have to get rid of the 3. We also need to get rid of the 7. So to get rid of the 3, we would have to divide, and I really don't want to divide right now because it's not going to create nice numbers. Whenever you're solving equations, you always save division for the end. So we are actually going to focus on getting rid of the 7. So the 7 is being added, so to get rid of it, I'll subtract. And if I subtract from one side, I need to subtract from the other side. So the 7's are gone. We're left with 3x equals negative 21. And now is where we can go ahead and get rid of that 3. So the 3 and the x are being multiplied. So to undo that, I will divide. If I divide one side, I got to do it to the other. And we're going to end up with x equals negative 7. So we think that our x equals negative 7. So we're going to go ahead and check it. might get a little squished here, but I'm going to try to squeeze in our check here. So I rewrite my original equation, but I take the x out and I plug in what I think the solution is, which is negative 7. So if we follow order of operations, we should do multiplication first. 3 times negative 7 is negative 21. Bring down our plus 7. We want to know, does that equal negative 14? So if you do negative 21 plus 7, it does in fact equal negative 14. Left side equals the right side. Go back and box your final answer. So that's an example of every type of equation you could see on your test. Make sure you get some practice. Go to your homework, get some extra practice on these. I can give you some more if you'd like. Just let me know if you're having trouble with solving equations.